So in this video, we're going to talk about how to solve formulas with radicals. So radicals are used in many formulas to solve science, math, and business problems. So this example that's on the title slide, the distance formula, is one that you've most likely used before. So you can solve these problems using the steps that we've been talking about in this lesson. So remember our strategies for solving word problems. Whenever you have a word problem, you're always going to start off by understanding the problem. Remember, that means you're going to underline, circle, or outline the important information. Then we're going to make a plan. So this involves setting up an equation and using any formulas that are required. Then you're going to work on solving. Remember, when you're solving, you want to show all your work and remember to go back and check your solutions. Finally, we're going to reflect on our solution and make sure that our solutions make sense in the context of the problem. So when we solve formulas with radicals, we're going to follow these steps, read the problem carefully, identify variables, determine any equations or formulas, and then when we solve the problem, we're going to use the steps that we've been talking about in this lesson. Isolate the radical, raise everything to a power, and then solve for the variable and check your solutions. So let's try this example. The length in feet of the string of a pendulum that requires 1.57 seconds to complete a full swing outward and back can be approximated by solving 1.57 equals 2 pi square root of L over 32 for L. What is the length of the string and the pendulum? So we're going to use 3.14 for pi. So we have the length in feet of a string of a pendulum, and it requires 1.5 seconds to complete a full swing. Here we have a formula that we're going to need to use, and it wants us to find the length of the string and the pendulum. And it gives us 3.14 for pi. So let's outline the important information. So we have L equals the length in feet of string and pendulum, right? So L is exactly what we need to find. And it also gives us this important formula. We have 1.57 equals 2 pi, the square root of L over 32. So we need to solve this formula for L, right? That is our goal right here. So remember, our goal is going to be finding L, but remember, we always want to isolate the radical when we're working with an equation that has a radical in it. So we're going to start off by doing that. Well, the reason the radical is not by itself is because it has a 2 pi with it, right? So we can divide both sides of this equation by 2 pi. And so that gives us 1.57 over 2 pi equals the square root of L over 32. So since it gives us a value to use for pi, I'm going to go ahead and plug that in. So this is like 1.57 over 2 times 3.14 equals the square root of L over 32. So when I simplify that, I have 1.57 divided by 2 times 3.14, and that gives me 0.25. So I have 0.25 equals the square root of L over 32. So remember that 0.25 is the same thing as 1/4. So that's 1/4 equals the square root of L over 32. So now that I have this radical, since that's a square root, I can undo it by squaring both sides of my equation. So when I square both sides of my equation, I get 1 over 16 equals L over 32. So now I need to work on solving this equation for L, right? I have 1 over 16 equals L over 32. So remember, this is like a proportion problem, right? So this is one of those where I can do that crisscross multiply, right? And multiply across like this. So I get 16L equals 32. And then I can divide both sides of this equation by 16 in order to solve for L. So that gives me L equals 2. So that means L equals 2 feet is the answer to this problem. So remember, I always want to go back and check my solutions. So I have 1.57 equals 2 pi times the square root of 2 over 32. So that gives me 1.57 equals 2 times 3.14 times, and then that's the square root of 2 over 32. Well, 2 over 32, remember, can simplify to 1 over 16. So that's the square root of 1 over 16, which tells me that 1.57 equals 2 times 3.14 times the square root of 116, which is 1 over 4. So if I multiply that all out, I find that 1.57 does in fact equal 2 times 3.14 times 1 over 4, which is 1.57. So that answer is correct. And 2 feet is a reasonable length for a pendulum, right? So I know that my answer is reasonable given the context of the problem. So now you can go ahead and pause the video and try this problem on your own. So in this problem, it tells us that the radius of a sphere with a certain volume v is given by r equals the cubed root of 3v over 4 pi. And we're trying to find the volume of a sphere with a radius of 3 meters. So we're going to start off with this formula, and we're going to plug in what we have, right? We have the radius is 3 meters. So that gives us the equation 3 equals the cubed root of 3v over 4 pi. Well, now we need to solve this equation for v, but once again, we have a radical equation. So we're going to undo that cubed root by cubing both sides of the equation. And when we do that, we get 27 equals 3v over 4 pi. Then we multiply both sides of the equation by 4 pi, which gives us 108 pi equals 3v. And then finally, we divide both sides by 3 to find the value of v. So we have 36 pi equals v. If we use 3.14 instead of pi, we get 36 times 3.14, which is 113.04 meters cubed for our volume. So remember, to solve formulas with radicals, you're going to start off by reading the problem carefully and outlining or circling any important information. Then you identify the variables, determine any equations or formulas you need to solve the problem. Then we're going to solve the problem by isolating the radical, raising everything to a power to eliminate the radical, solve for the variables, and then check your solutions.